AI in agriculture. Precision agriculture involves using technology to optimize various aspects of farming with precision and efficiency. AI plays a crucial role in this paradigm shift, offering advanced tools for data analysis and decision-making. Crop monitoring. AI-enabled drones equipped with sensors and cameras can monitor crops from the air, capturing high-resolution imagery. Machine learning algorithms analyze these images to detect patterns related to crop health, nutrient levels, and the presence of pests or diseases. Yield prediction. AI models, often powered by machine learning, analyze diverse sets of data, including weather patterns, soil quality, historical yields, and crop health. By identifying patterns and correlations in these datasets, AI can provide accurate predictions of crop yields. This information helps farmers make informed decisions about resource allocation and planning. Pest control. AI is employed in pest control through the development of smart traps and monitoring systems. Machine learning algorithms can analyze data from these devices to identify patterns associated with pest presence. This allows for targeted and timely intervention, minimizing the need for broad-spectrum pesticides. Automated harvesting. Robotics and AI are being integrated into harvesting processes. Automated systems equipped with computer vision can identify and pick ripe fruits or vegetables, reducing labor costs and improving overall efficiency. Examples of AI technologies in agriculture. CropX utilizes soil sensors and machine learning algorithms to optimize irrigation. The system continuously monitors soil moisture levels and provides insights to farmers, enabling precise irrigation scheduling and water conservation. Blue River Technology, acquired by John Deere, develops AI-powered tools for precision farming. Their See and Spray system uses computer vision to identify individual plants and selectively apply herbicides, reducing the overall amount of chemicals used in the field. IBM's Watson Decision Platform for Agriculture leverages AI and IoT, Internet of Things, technologies. It provides farmers with real-time insights into weather conditions, crop health, and other factors, helping them make data-driven decisions to optimize yields. Gamaya combines hyperspectral imaging and AI analytics to monitor crop health. The system can detect early signs of diseases, nutrient deficiencies, and other stress factors, allowing farmers to take proactive measures. Benefits of AI in agriculture. Increased efficiency. AI technologies automate time-consuming tasks, such as monitoring crop health and predicting yields. This efficiency allows farmers to optimize their resources and focus on strategic decision-making. Resource optimization. Precision agriculture, enabled by AI, helps optimize the use of resources like water, fertilizers, and pesticides. This not only reduces waste, but also contributes to sustainable and environmentally friendly farming practices. Improved crop quality. By monitoring and managing various factors affecting crop health, AI contributes to improved crop quality. This is crucial for meeting the demands of quality-conscious markets. Cost reduction. Automated processes, predictive analytics, and targeted interventions lead to cost savings for farmers. Reduced use of inputs like water and pesticides can lower operational expenses. Challenges. Initial investment. Implementing AI in agriculture may require significant upfront investment in technology and training. This can be a barrier for small-scale farmers or those with limited resources. Data security and privacy. As AI systems collect and analyze sensitive data, there are concerns regarding data security and privacy. Ensuring robust cybersecurity measures is essential to protect farmers' information. Technical literacy. Farmers may need to develop new technical skills to effectively use AI-powered tools. Training programs and user-friendly interfaces are crucial to overcoming this challenge. In conclusion, AI is transforming agriculture by introducing precision, efficiency, and sustainability into farming practices. While challenges exist, the benefits of AI in agriculture are evident in improved yields, resource optimization, and the potential for more sustainable and environmentally conscious farming.